In this lecture, we do the weighted mean, mean of frequency distribution, range, and quartiles, these topics. Okay, weighted mean is the mean of a data set whose entries have varying weights. Okay, so we have the formula for weighted mean. This is the formula for weighted mean. Weighted mean is the sum of the product of the number and the weight divided by the sum of weights, where W is the weight of each entry, X. X is the number, data number. Okay, we'll do this question and then we understand what are these weights and how do we multiply the numbers and the weight and how we get the sum, and then we divide by the sum of weights, and that's how we get the mean. So we do in this question. Okay, so let's say you are taking a class in which your grade is determined from 5 sources: 50% from your test, 15% from your midterm, 20% from your final exam, 10% from your computer lab work, and 5% from your homework. Your scores are 86, the test mean, 96, the midterm, 82, the final exam, 98, the computer lab, and 100, the homework. What is the weighted mean of your score? And if the minimum average for an A is 90, did you get an A? Okay. You can use calculator to obtain this. Okay, so this is the question. So what we have here is we have the various items and their weights, right? So your test score 86 and the test has 50% weight. These percentages are the weights. Okay, so test has 50% weight, 20% is the final exam, so final exam has 20% weight. So each item has different weights, right? So that's how we usually calculate your overall grade. Like not all assignment are same percentage, but some counts more and some counts less, right? So that's how we do that. That is the weight of those items. Okay, so what we have here is we put it like this. We have scores and weight. Okay, score and weight. Score are X. These scores, these are X. Like 86 is the test score, right? So 86 is the score, and the weight is 50%. Weight is 50%, so you can write 50 or you can write 50%, so 0.5, 0.50. That is the weight. You could write 50, okay? So we can write in either way. You can write 0.50 for the percent, or you can simply write 50. You will get the same answer, okay? You will get the same answer. So 86 has 50% weight. Midterm is 96, right? So midterm counts 15%. So 96, you get 96 in midterm and that counts 15%. So 0.15. Okay, that is the weight. 82 in the final exam. So you have 82 and the final exam counts 10%. 0.10. Okay. Computer lab 98, so you got 98 in computer lab and that counts 10%. Wait a minute, here 20% from final exam, and we got final exam 82, so that counts 20%, so that is, this is 20.20. okay, 98 is the computer lab, right? So 98 is computer lab and computer lab counts 10%, so this is 0.10. and 100, you got 100 in homework, and that counts what? 5%, right? So 0.05. So these are the score. The score are X and weight is W. Okay, so that's how we draw a table with all X and W, the score and the weight. Okay, now you what you do now is you can add the total weight. So you add these numbers, you get the sum of W, the sum of weight, and the total is 0.100, 0.50, 0.15, 0.20, 30, 50. So what you get here is 30, 45, 50, 50. So 1. The total W is 1 because 100% is 1. Okay, so see, we got what? We got the sum of W, right? So we got the sum of W, we add all the weights. So sum of W is 1. And now we need this item, X times W. So what you do here is you add one more column. You add one more column and you multiply X and W. Okay, 86 times 0.50. So 86 times 0.50 is 43. 43. 96 times 0.15 is 14.4. 82 times 0.20 is 16.4. Okay, 98 times 0.10 is 9.8, and 100 times 0.05 is 5. This is 43.0. Okay, so we multiply these two numbers and we write here. So this times this is this, this times this is this, this times this, and multiply that. And now you add these. You add X times W, this whole thing, and you get 88.60. Now the weighted mean equals to the sum of X times W divided by the sum of W, right? So this is equals to the sum of X times W. The sum of X times W is 88.60 divided by 1, and this is the same number, 88.60. So this is the weighted mean for this data. Okay, so when you see percentage for some item, those percentage count the weight, and the other number, like you can have score or some other thing, that goes for X, and percentage always goes for weight. Okay, because percentage counts weight. So that's how we do. So the percentage is weight, scores are X, multiply and add, and then you divide. So this formula is what we apply to find the weighted mean. Okay. All right, now let's see the next question. Let's do the next question. Your grades from last semester are in the table. The grading system assigned point as follows: A equals to 4, B equals to 3, C equals to 2, D equals to 1, F equals to 0. Determine your grade point average. The GPA is weighted mean. Actually, when you get the GPA, that GPA is the weighted mean. Because you take courses which some of which are 3 credit course, some of which are 4 credit course, and 1 credit course, 2 credit course, right? So if you get A in 4 credit course, and if you get an A in 1 credit course, there is a difference. If you make A in 4 credit course, your GPA will be more. Like you have 2 courses. Let's say you have 2 courses. In one course, in one is 3 credit course and one is 1 credit course. Okay, let's say 4 credit course and 1 credit course. If you get A in 4 credit course and C in 1 credit course, that gives you higher GPA than you get C in the 4 credit course and get A in the 1 credit course. Okay, so because of the weight, if you get A in higher in more credit course, then your GPA will be better. Okay, that is what this question is trying to explain. Okay, so here is the grades that you get, and these are the credit hour courses that you have. Like C, you got C in 3 credit hour course, and you got C 4 credit, and D 1 credit course, A in 3 credit course, C in 2 credit course, and B in 3 credit course, right? Okay, so points. So how much point you get for how many which courses with what credit hours? C has 2 points. Okay, see, C has 2 points. So you got 2 points for 3 credit hour course, right? So credit hour is W and the point is X. Another C is 2 points for 4 credit hours. D has 1 point for 1 credit hours. A has 4 points for 3 credit hours. C has 2 points for 2 credit hours. And B has 3 points for 3 credit hours course. Okay? Alright. So you get these points for these credit hours. Alright. Now let's do this. Now we add one more column where we need to multiply the 2 items. Like we do X times W, 2 times 3. So you got 2 points for 3 credit hour course, right? So you multiply 2 times 3, 6. 2 times 4, 8. 1 times 1, 1. 4 times 3, 12. 2 times 2, 4. 3 times 3 is 9. See, you got A in 3 credit course, so your total weight is 12, right? So total point is 12 points because you multiply. 4 times 3 is 12. But if this was a 1 credit course, you could get 4 times 1 is just 4, right? So you get less points in that way. But because of the 3 credit hour course, you got A, so that gives you bigger points, larger number. Okay, now we add the sum of X times W. We add these numbers. So 12 and 4, 16, 16, 9, 25, 26, 26 and 6 is 32, and 8, 40. So you get 40. Okay, and then you add the W, the total weight, 7, 8, 9, 10, 11, 12, 13, 15. 15, right? So your GPA or weighted mean equals to the sum of x times w divided by the sum of w. So this is equals to 40 divided by 15. 40 divided by 15 is, what is that? 15 times 2. Let's do my calculator. 40 divided by 15, 2.67. This is the GPA. Okay, so if the scores are these with these credit hour scores, then the total GPA is 2.67. So what we learned from these two questions is percentage is the weight and the credit hours is the weight. Okay, and when we multiply the number and the weight to find the product of x and w, we add them, we add the w and then divide by this. Okay, now question 3. The numbers 90, 35, 20, 55, 70, 75 have weights 6, 5, 4, 2, 2, 1 respectively. What is the weighted mean? Okay, right. So here, what are x and what are w? See, these numbers are the x, and these numbers are weight, because this says that weights these, right? So 90 weight is 6, 35 weight is 5, 20 weight is 4, 55 weight is 2, oh, sorry, this one, 70 weight is 2, and 75 weight is 1, right? And then you have to find the weighted mean. So what we did here, we multiply the number and the weight, right? So that's what we get here, right? So these are the numbers, and multiply the number and weight, you multiply, you get here, and then you add and then you divide by the total weight, right? So we do the same thing. So what you do here is you multiply 90 and 6, because 90 has weight 6, right? So 90 times 6 plus 35 times 5 plus 20 times 4 plus 55 times 2 plus 70 times 2 plus 75 times 1, right? So what we did, we multiply, just like we got these numbers here, right? So we multiply these two and we got this number. So we got multiply and the sum, right? You add, and then you divide this whole thing by the sum of these numbers, right? So 6 plus 5 plus 4 plus 2 plus 2 plus 1. Okay, so what you get, let's see. Okay, when you calculate these, the top part, 1120, you get 1120 divided by 654,221 is 20. Okay, so 1120 divided by 20 is 56. So the weighted mean is 56. Okay. Alright, now this is in Bobby's school, math grade for the year are calculated from assignment, test and final exam. Assignment count 30%, test count 20% and the final exam 50%. If Bobby has assignment grades of 85, test grade of 72 and exam of 61, what is Bobby's overall graded weighted grade? Okay, so we do the same thing, right? So what we do here is these are the numbers 85, 72 and 61. These are the numbers, okay, and these are the weights 30%, 20% and 50%. These are the weight. Okay, so you can do it this way. Here we have less space, so we do 85 times multiply 85, because 85 is for assignment and assignment counts 30%. 85 times 0.30, right, 30% plus test grade is 72. 72 times 0.20 plus 61 times 0.50. Okay, so you divide this thing by 0.30 plus 0.20 plus 0.50. Okay, and then you can find out you can calculate, you can simplify, and you get you multiply the top these two numbers, and then these two numbers, and then these two numbers, and then you add. Okay, first you multiply and then you add. Okay, and then you divide by the sum of these numbers. This sum is 1, so just divide by 1. So the answer for this question is, like, I have to calculate. Let me calculate this. Let's see. Uh, 85 times 0.30 plus 72 times 0.20 plus 61 times 0.50, 70.4. Okay, so 70.4, this is the 70.4. Okay, so that is the weighted mean. All right, now so this is the process to find weighted mean. You have the weight given in the question, and you have the numbers given in the question. The only thing is you need to identify which one is weight and which one is the number, the data number. Usually the percentage and the credit scores go for weights, and if you have in the question, if it says like these are the weights, then these are the weights, so you get the weights. So figure out which is the number and which is the weight, and then you multiply those numbers, the number and the weight, and add them, and then you divide by the total sum of the weights. Okay, so that's how you get the weighted mean. Okay, now the next is the mean of group data. So now when you have a group data, you get a group like this, say 29 to 33, frequency 11, 34 to 38, frequency 12, 39 to 43, frequency 2, 44 to 48, frequency 5. So how to find the mean from this data, from this type of data? The one we did in the previous lecture was we didn't have like this type of data. So we just had the numbers, right? So we added those numbers and then we divided by the total number of observations. But here it is, we have a class, we have class, like this to this class, this to this class, we have classes, and we have the frequencies. And so what we do, here is usually the process for this is find the midpoint of the class. Okay, the midpoint of the class, and that counts, that that represents x. The midpoint represent x, and the frequency is f. And just like we did multiply the number and the weight, we do multiply the number and the frequency. Okay, so that number is the midpoint of the class. Okay, so midpoint, which number is in the middle of 29 and 33? So that number we choose, and that number we multiply with the frequency. Okay, so that we get x times f. F is the frequency, x is the number, that midpoint number, that middle number. And then you add those numbers, those products, and then you divide by total frequency, total f, total number of sum of frequency. Okay, so that is the process, and these steps I write here is exactly what I said. And how to find the midpoint of the class? You can either count and figure out by yourself, or you can add these two numbers and divide by 2. Like 29 and 33 is 62, divided by 2 is 31, right? So the midpoint of 29 and 33 is 31. Or you can think like 29 and 33, so which number is in the middle? So 29, and then we get 30, 31, 32, 33, right? So we 29, 30, 31, and we have 33, so 32, 31. So we get 31 in the middle. Okay, so 31 is the midpoint of the class. 34 to 38 is 35, 36, 37, 38. So 36 is the midpoint. 39 to 43 is 41. 41 is the midpoint, and 44 to 48 is 46 is the midpoint. Okay, so these are the midpoints of the class, this class. Okay, so let me write here that if you can figure out, just do what is to find midpoint. To find the midpoint, you do 29 plus 33 divided by 2. So you get 62 divided by 2, which is 31, right? And so this 31 is the one you put here. Okay, so that's how we get these midpoints. All right, now we multiply x and f. So we multiply x times f, because we need this formula, sum of x times f divided by n, right? So 11 times 31 is 341. 12 times 36 is 432. 2 times 41 is 82. And 5 times 46 is 230. Okay, so we multiply the number and the frequency. Multiply the number and frequency. Okay. Okay, so let's see. All right, so now you add the sum of x times f. This is the sum. You add these numbers, you get 1085. 1085, and you also add this sum, the sum of f, these numbers, and this is 30. Okay, so this is the sum of f and sum of these numbers. Now the mean x bar equals to the sum of x times f divided by the sum of f, and this is equals to 1085 divided by 30. and this is 36.17. Okay, so this is the process to find the mean of any frequency distribution of the group data, the mean of group data. So you find the midpoint and then multiply by frequency, and then you add the sum of you add the multiplication of you add the product of x and f, and you add the frequency, and then you divide. Okay, so this is how you find the mean of group data. If it is not a group data, and if it is simply a frequency table, like you have a number and frequency, you have a single number and a frequency, you have a single number and frequency, if you get that type of data, then you do the same thing, right? The thing is you have a number to multiply there, but here in this data you don't have a fixed number, you don't have a specific number, so you find the midpoint. But if you are given a number, then you can multiply the number. Okay, so it is the same process. Okay, so let's go to the next page. Okay, here now we did the weighted mean and mean of frequency distribution. Now we are in range and quartiles now. This page is the range and quartiles. Okay, so what is a range? The range is the difference between the largest and smallest value in the data set. The formula is range equals to maximum value minus the minimum value. Okay, so this is the formula for range. The range is simple to compute and easy to understand, but it uses only the extreme values. So it uses the maximum value and the minimum value and ignores the other values. Therefore, it is affected severely by outliers. You know, those outliers are either the maximum number or the minimum number, right? Because outliers are either a big number or a very small number. So when you find the range, you need to take those maximum and minimum number, right? So if there is an outlier, that affects the range. So range is affected by outliers. Mean is affected by outliers, and range is affected by outliers. The median and the mode, those are not affected by outliers. Okay. Now question 7. The height of 20 adult males are listed below. Find the range. Okay, so we find the range. So what is the minimum number in the data? The minimum number of this set is 67. Okay, so the minimum equals to 67 and the maximum equals to 74. So the range equals to 74 minus 67, which is 7. Okay, so this is the range. So we always do that, we subtract the maximum and minimum number. Okay, so subtract minimum number from maximum number. Now quartiles. Quartiles are those values which divide the order set. Of data into 4 equal parts. See, 25%, 25%, 25%, 25%. We did median, right? So median is the middle number in a data set. The quartiles, see, the median divides into 2 halves. So take the first half and find the middle number again. That middle number is the first quartile. And take the second half and find the middle number again. So that is the third quartile. So quartiles are those numbers which divide the whole thing into 25% of each. So these numbers, these three numbers divide into 25%, 25%, 25%, and 25%. So these numbers are called quartiles. Okay. So just like we have 4 quarters in $1, just like that. Okay. So we have a data and we get 1/4 of each data. Okay. Now 25% of the first quartile. See, 25% of the data is below the first quartile, Q1. 25% is between the first quartile and the second quartile. 25% is in between the second quartile and third quartile, and 25% is from third quartile above third quartile. Okay, the second quartile is also known as the median. So median is the second quartile. Okay, so now steps to find quartiles. We'll do this question, and then these steps are there. You can read these steps. So what does these steps say? You have to first arrange the data in order. That is a must, because you have to do the arrange in increasing order or in decreasing order. Oh no, first you do increasing order, because you find Q1, Q2, Q3. And if it was just the median, then it doesn't matter if you put in increasing order or decreasing order. But if it is a Q1, Q2, Q3, you put in increasing order. Okay, so that is the way to do. First you put the data in order and then consider the median. So find out the median, and this is the second quartile, Q2. Consider the lower half of the observation, excluding the median itself. Okay, so don't take the median and then take the other half. Okay, you take the first half, but don't include the median, and take the first half and find the median again. Then that is the first quartile. And then you take the second half and then you find the median again. So that is the third quartile. Okay, you see what I am saying? You first put the set in order, the data in order, and then you find the median, and then that median is a number, right? So that median is a number. So don't take that number, don't include that number, and take the first half and find the median again from the first half. That is the first quartile. And then find the median again from the second half. That is the third quartile. So that's how we find the quartiles. Okay, so let's see this one. Find the range, upper quartile, lower quartile, and median of the data. So there are two questions. So let's do. First we put in order. Put the data in order. Okay. So 1, 2, 3, 5, 7, 9, 7, 8, 9, 11, 12, 14, 15. Right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So we put this in order. Now, you find the median. So what is the middle number? So 1, 2, 3, 4, 5, 6. Let's see, and then 1, 2, 3, 4, 5, 6. This is the median. Okay, so this is the median, and median is 8, which is the second quartile. Median is second quartile. Now take the first half. Take the first half. Don't include the median now, because you got the median, so you are done with the median. So just take the first half, and then starting at 9, you take the second half and find the median in this half. So now in this half you got 5 numbers, right? So which one is the middle? 3. So this is the median from the first half, and this is the first quartile. First quartile Q1. Q1. Okay, so this is 1. And from this half, the median is 12. This is the third quartile, Q3. Q3. So we get the lower quartile. First quartile is called the lower quartile. The second quartile is called the median. And third quartile is called the upper quartile. The first quartile, the lower quartile is 3. The second quartile is 8. The third quartile is 12. Okay. And the median is 8. Now range. Range is the maximum minus minimum number. So the range is 15 minus 1 is 14. 14 is the range, and these are the quartiles. Okay, now the next question. Here is, now put them in order first. So let's put these numbers in order. 1, 2, 3, 5, 8, 9, 11, 12, 14, 15. Okay, so this is in the order. So we put them in order. Now we choose the median, right? So what is the median? So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we got 10 numbers here. So we have 2 numbers in the middle. Which 2 numbers? Let's see, 1, 2, 3, 4, 1, 2, 3, 4, these 2 numbers. Okay, so these 2 numbers are in the middle, right? So these 2 numbers are in the middle. So the median is, how you find the median? You do 8 plus 9 divide 2. Okay, so this is 8.5. This is the second quartile. Okay, now the thing is, here we had the median in the data, but here the number median is not in the data, right? So this is a number which is not in here. So what I said here is, you don't take the median and take the other numbers, right? So here the median is 8.5, which is not here, which is not 8, which is not 9, which is 8.5, right? So that is 8.5. So when you take the first half and the second half, what you do now is you take 1, 2, 3, 5 and 8. You take this set and then you find the middle number. See the two different things, right? Here we don't take 8, but here you take 8, because 8 is not the median. Median is 8.5. Median is in the middle of 8 and 9, which is not 8. So we take 8. So we consider 8 for the first half, and we get the first quartile Q1 equals to 3. And when you take the second half, you include 9 and get the second half, and then from there you find the median, right? So this median is now Q3. So Q3 is 12. Okay, so the answer is Q1 equals to 3, Q2 equals to 8.5, Q3 equals to 12, and the range is 15 minus 1 is 14. Okay, see that. So the difference is when you find the median, then look at that number. If the number median is in the data, basically if you have an odd number of data, then you will get the median in the data. Okay. If you have an odd number of data, you don't include the median to count the first and second half. But if you have a even number of data, then no matter if the number is in there or the number is not there, you have to consider the half of the data as first half and the half of the data as second half. Okay, so is that clear? So it is possible that the number is sometimes, like here is 8.5, which is not here, but sometimes it is possible that you get those numbers in there, right? That median you get here. But even though you get the number, if you have an even number of data, consider one half, the complete one half set the first, and the complete one half is the second half, and then from there you find the other quartiles. Okay, so that is the thing. Okay, so that's the thing. Okay, now we do this question and see what types of data we have here. This is again the range and upper quartile, lower quartile, and median of the data. Range is easy, like you have 340 is the largest number and 0 is the smallest number, so range is 340. So that's not a big thing. The thing is, like, we need to put them in order and then you choose, so that's the thing. So let's first put these numbers in order. Let's put these numbers in order. Okay, so 0, and so 0 is there. 70, yes, 70, and then, oh sorry, 50. We got 50 here, so we have 50, and then 70, 100, right? Yes, so 100, and then 140, 130, right? So 130, 140, 140. So 130, 140, 140, 160, 150, 150, 160, 150, 160, and then 180, 180, 180. So 180, 180, 180. Okay, and then 200, 190. We got 190, and then 200, 210, 200. Oh, sorry, 200, 200, 210, 210. So we got 200, 210, right? And then 220, 220, and 340. Okay, so these are the numbers: 220, 290, and 340. Sorry, 290. Yes, you be careful when you do this, don't miss any. 290 and 340. Okay, so 290 and 340. So how many? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 17, 18, 19, 20 numbers. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so this is the data. Okay, so let's do this. Okay, now this is the data. Now let's choose the middle number. So because there are 20 numbers, 10.5, so you get 10 and 11 numbers, two numbers in the middle, right? So you can choose like 340, 0, 290, this 70, 100, 130, 140, 140, 150, 160, 180, 180. So you get these two numbers in the middle. Okay, so those 280, and that is what exactly I was saying. See, now you got two numbers in the middle, right? So the median is from here. The median is, you add these numbers and divide by 2. 180 plus 180 divided by 2. So 360 divided by 2 is 180. So you get 180, the median. You have 180 there, right? So you got the same number, but it doesn't matter because you have the even number of data, and you got this number by adding these two numbers and dividing by 2. So when you take the first half, you start at 0 and then you take this 180. So you take this whole thing as first half. This is not the answer, but I'm saying that this is the first half, and then you take this as second half. Okay, so this is second half. Okay, I do this to separate them, the first half and second half. Okay, now you choose the median again from this half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you got 10 numbers here. So 1, 2, 3, 4, 5, 6. So these two numbers are in the middle. Okay, so from there you get the first quartile. Okay, so the rule is same, because just like you find the median if you have two numbers in the middle, like you got these two numbers in the middle and you add and divide by 2, you do the same thing for quartile. Okay, so this is 270 by 2, which is 135. This is the first quartile, and here 1, 2, 3, 4, 5 and 6, so these two are in the middle. Okay, so there you do Q3 equals to 200 plus 210 divided by 2, and this is 410 divided by 2 is 205. Okay, so this is the first quartile, the second quartile, and the third quartile. And it says the range is 340 minus 0. Okay, so this is the process. Now here I guess this is the last question. We have one more. The test score of 15 students are listed below. Find the first quartile. Now we just need the first quartile. Okay, so this is in the order. This is in order. So 44, 46 is. So we got how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers, right? So 15 numbers. So let's count the middle number. So this is the middle number, 70. So that is the median, right? Now you got, if you have this odd number, don't include the median now for the first half. So we include 1, 2, 3, 4, 5, 6, 7 numbers only, and from there you find the median again. So 1, 2, 3, 1 2 3. So that is, this number is the first quartile. And this is the median. So 57 is the first quartile. Okay, so see the difference in data if you have an odd number of data and you have even number of data. So how to find the median and the quartiles, the Q1, Q2, Q3. Now the definition here is interquartile range. The interquartile range is the distance between the third quartile and the first quartile. Distance is difference, like you subtract the third quartile minus the first quartile. So that is the interquartile range, and this is the formula Q3 minus Q1. Interquartile range is Q3 minus Q1. Okay, so subtract Q3 and minus Q1. Find question 11. Find the interquartile range of the data given in question 9. So here is question 9. Okay, so here is question 9. You find interquartile range. Okay, so we do interquartile range equals to Q3 minus Q1. So Q3 is 205, right? So we got Q3, 205 minus Q1 is 135. So what is that answer? So 5 minus 5 is 0. 0, 10 minus is 70. Right? So 70. 70 is the interquartile range. Okay, so we did the median, we did the quartiles, we did the mean of weighted data, weighted mean of the data, frequency distribution, mean of the frequency distribution, mean of group data, and we did range, and we did the quartiles. We did the quartiles for odd number of data, we did the quartiles for even number of data, and we did interquartile range. So these many topics we did today. So we'll stop here, and in the next lecture we will do some other stuffs like a standard deviation, a variance, and those things we do in the next lecture. Okay, so I'll stop here and I'll see you in the next video. Thank you.